relationships between the sides and the angles of triangles. And so that's actually what trigonometry means. Okay, trigonometry actually comes from the root words trigon, which means triangle, and metry, which means measurement. And so when you look at the root words, it means triangle measurement. And that's what we're going to look at today. And this is something that will follow you through. You'll actually probably use this more in life than probably anything else that we've learned this year. And so we're going to start by talking about the trigonometric ratios. Trigonometric ratios deal with right triangles only. They have to have a 90-degree angle. Okay? And so we have three trigonometric ratios that we can deal with. Okay? We have sine, we have cosine, and we have tangent. So you need to make sure you get those down. Sine, cosine, and tangent. And we're going to break those down individually, and we're going to look at what each one of those means. So you have three trigonometric ratios, and you're going to see these on your calculator. Okay, they are abbreviated SIN, COS, and TAN. So on your calculator, you're going to notice somewhere where it says SIN, COS, and TAN, and you probably always wondered, deep down, what do those mean? Well, today you're going to find out. Okay? So, let's go ahead and start by breaking each one of them down. Now, in a right triangle, we have three parts. We have the opposite side, the adjacent side, and the hypotenuse. The hypotenuse is always the longest side. It's always opposite the right angle. So which one is the hypotenuse? AC. Good. So here's our hypotenuse. Now, if you notice here, I'm referring to angle C. For those of you watching, you're probably wondering, what does she mean in angle C? Here's the angle C I'm referring to. So that means I start at angle C, which is right here. And I'm going to now identify the two remaining sides of the triangle as either opposite or adjacent. Opposite means it does not touch the angle at all. Adjacent means it's right next to the angle. So of those two remaining sides, which one would be the opposite? AB. Okay, so here we go. Here's my opposite side. And then that leaves the BC as to be the adjacent side. Okay. Now, when I'm referring to the sine of angle C, sine is always defined as opposite divided by hypotenuse. So there's your opposite. Here's your hypotenuse. It's always defined to be that. Cosine is always defined to be the adjacent over the hypotenuse. Want to take a guess as to what tangent is? Okay. Opposite over adjacent, right? Okay. Now, there's a nifty little way to remember which goes with which. And that's what is known as SOHCAHTOA. Now, I don't know if you've heard that before or not, but if you write it out, you will see that the first letters all correlate. So, SOHCAHTOA. So, there's so. Here's ka, and here's toa. So there's your SOHCAHTOA. That's where it comes from. Biggest thing, you need to get those down. You need to know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. You've got to know those. That's the bottom line. Let's go ahead and look at what we have on the next slide. Find the value of x. Find the value of x. So this is my angle right here. So I'm going to identify the three sides that I know. Which one is your hypotenuse? It's the one that doesn't have a side, right? So you could abbreviate this H if you wanted. What side is your opposite? 23, because that's the opposite the angle. What side is your adjacent? 11, because that's the one that touches the angle. Always start with your hypotenuse, then fill in the others. And so let me see what I know. I know three things. I know the angle right here. I know this side right here. And I know this side right here. So I know opposite and adjacent. which of the three trig functions only uses opposite and adjacent? Tangent. Now how we write this is we write this as the tangent of the angle equals opposite over adjacent. So what would it be? 23 over 11. Good. So now what I need to do is I need to go ahead and divide 23 divided by 11. What is 23 divided by 11? I want to go to 4 decimal places. 2.09 repeating? Okay, now I need to solve this for x. And so you're going to notice on your calculator there should be a button that looks like this, and it says tan -1. So what I need you to do on your calculator is I need you to hit that tan -1 button and then type in 2.0909. If you have one of the Texas Instrument ones that doesn't allow you to see what you type in, doesn't let you write it as a sentence, you have to do it the backwards way. So you have to type in 2.0909 and then hit inverse tangent. Okay, that's you. Actually, that whole back group in this one, you can type it in exactly as you see it here. What did you get x to equal? This time we're going to 2 decimal places. 64.44 degrees. And so that is what x equals.
Is it always 2?
Yes. Okay, throughout the problem, if you want to go ahead and use 4, that would be great. And then do 2 to round. Now it's your turn. Okay, I want you to set this one up for me. So what trig function did you use? Sine? Not sine. Sine, okay. So sine of x equals what first? 9 over 29, good. And then, now I've got sine of x equals what? Okay, now how do I solve that? Okay, this one, since it's sine, I'm going to use this button on your calculator. Okay, the inverse sign. We call that the inverse, it undoes sine. So you're going to use the sine to the -1. And when you do that, what do you get your angle to be? 18.08. Okay, questions? Okay, here we go with another one. Now this one, okay, this one's a little bit different. What are you going to use for your trig function? Yep, opposite over adjacent. So I have tangent of x equals 27 over 8. What'd you get 27 over 8 to be? 3.375, good. Now what I need to do is the tan -1. What? 73.49. Is it 495? Okay, so really that would be 73.50. Okay, oops, let's go back. All right, so let's look at this one. Let's look at the 3 things we know. This, this, this. Best way to do this is identify what we know. What's the 19? What's the x? Adjacent. What ties in adjacent and hypotenuse? What ties in adjacent and hypotenuse? Cosine. Now, if you remember, it was always cosine of x or cosine of whatever the angle is. What's the angle in this problem? 33. So this is the cosine of 33 degrees equals, what do you think? X over 19. So now this is a little different because we haven't had a problem where it's like sine of an angle or cosine of an angle. Okay? And so in this case, I need to use my calculator and I need to know what this is to 4 decimal places. Now make sure you use the cosine button, not the cosine with the -1. So I'm just looking for the COS 33 degrees. What'd you get? Should be point and then I want 4 decimal places.
0.7771.
Okay, you need to make sure that your calculator is in degree mode. Okay, so what is it again?
0.8387.
Okay, 0.8387. That equals x over 19. Now this is just a basic equation we need to solve. Notice I've taken x divided by 19, so to undo division, I times it by 19. So if I times this by 19, what do you get to 2 decimal places? 9.3?
It's 9.3.
Okay, we've got one more problem we're going to look at. Oh, let's go back. There we go. At a distance of 36 meters from a tree, the angle from the ground to the top of the tree is 31 degrees. Find the height of the tree. All right, so now let's go ahead and look at what I'm given. They want to find the height of the tree, so the height of the tree is over here, h. So let's see. I've got an angle, I've got this side, and I got this side. So let's label. What is height? What side is that?
Opposite.
Opposite. What side is this?
Adjacent.
Adjacent. What ties in opposite and adjacent? Tangent. So tangent of the angle. So tangent of what? 31 degrees equals what, folks?
0.600.
Equals h over 36.
Oh.
Yep. Just jump the gun. That's okay. So now what is the tangent of 31 equal?
0.6009.
6009. Somebody else get that?
Yeah.
Okay, how do I solve this now?
Times it by 36.
Times it by 36.
21.63.
So I get 21.63. My label would be meters. Questions? Okay, we're going to spend a couple days on this stuff. Okay. So, anyway, your assignment from this section is on page 644 through 645, 1 through 19.
Are we not using that
Okay,
expression?
so.